we need to eliminate the parameter t, then use the rectangular equation to sketch the plane curve represented by the given parametric equations. Use arrows to show the orientation of the curve corresponding to increasing values of t. Okay, so whenever we have an x value and a y value that have cosine and sine as part of it, I would use the general equation that sine squared of an angle plus cosine squared of an angle is equal to 1 in order to change this into a rectangular equation. So to do that, we need to solve each of our equations for cosine and sine. If we subtract 1 on both sides, we get x minus 1 is equal to 4 cosine t. And then divide both sides by 4, we get x minus 1 divided by 4 is equal to cosine t. Doing the same idea, solving for sine in our y equation, we can first add 1 on both sides to get y plus 1 is equal to 3 sine t, and then divide both sides by 3 to get y plus 1 over 3 is equal to sine t. Now that we have it solved, each equation solved for the cosine or the sine, we can plug into our overall equation. The sine squared would be taking the sine t and squaring it. So that would make y plus 1 over 3 squared. And then plus, we need to do the cosine squared, which we can substitute the x minus 1 over 4 in for cosine. We just need to square it. So x minus 1 over 4 squared, and that is equal to 1. Simplifying it a little bit to make it more like a regular ellipse equation, we would square the denominators to make that y minus 1 squared over 3 squared is 9, plus we'll leave the x minus 1 squared on top and square the bottom. 4 squared is 16, and that is equal to 1. So here is our eliminated the variable t, the parameter t, rectangular equation. From here, we need to sketch the plane curve. And we know that t only goes from 0 to pi. Since we know that this is like an ellipse shape, what we can do is just plug in a few values of t between 0 and pi. So I'll make a little chart with t and x and y. We need to have at least 3 values of t. So let's pick 0, pi over 2, and pi. If we plug in 0 in for our x equation, the cosine of 0 is 1. So I would make 1 times 4, which is 4, plus 1 makes 5. So our x, when t is 0, x is 5. Then if we plug in t is 0 into our y equation, sine of 0 is 0. So then 0 times 3 is 0, and that would just leave us with negative 1. So that gives us 1 point. If we draw a little sketch of our graph, we know that when x is 5, y is negative 1. So this side's going to be x, this is y, and x is 5, y is negative 1. So our first point will be about right here. Next, let's plug in pi over 2. If we plug that into our x equation, the cosine of pi over 2 is 0. So this whole term goes to 0, and it just leaves us with 1 for our x value. Then if we plug in pi over 2 in for our y equation, sine of pi over 2 is 1. So that would be 1 times 3 is 3, minus 1 is 2. So when x is 1, y is 2. Let's graph that. When x is 1, y is 2. And we're going so far like in this direction. We know it's in an ellipse shape, so we know it's going to be a fairly smooth curve. This looks something like that. And we know it's an ellipse shape because of the rectangular equation that has the like x minus h squared over a squared plus y minus k squared over b squared is equal to 1. It's in this kind of form, so that's how we know it's in a ellipse kind of shape. Okay, next we plug in pi for the x equation. The cosine of pi is -1, so that would be -1 times 4, which is -4, and -4 plus 1 is -3. And then, whoops, that doesn't look much like a 3. Let's try that again. Okay, that's better. Plugging in pi for sine, the sine of pi is 0. So this term goes to 0, and it leaves us just with -1. So our last point over here would be x is -3 and y is -1. So our curve is going to come back down like this. And because we started on this side and we ended on this side, we know that our arrows would need to be pointed in this direction. Okay, so I hope that was helpful for you. If it was, please like the video and share with anybody you think might find this information useful. Thanks for watching.